Today we're going to focus on rocks. So basically, what are rocks? Rocks are a mixture of minerals. So a rock is a naturally occurring solid mixture. So the focus is it's a mixture. Remember, not a compound, but a physical mixture of one or more minerals or organic matter. Rocks are basically classified by how they're formed, what they're made up of, and their texture. Rocks change. They do change over time through the rock cycle. We'll talk about the three types of rocks in the rock cycle. Okay, here's the rock cycle. You can see on the right-hand side, we have the igneous rock, it's a sedimentary rock, and the metamorphic rock. So we're going to be explaining how the rock cycle actually forms. It does not have to go in the order of igneous, sedimentary, metamorphic. Let's look at some of the terms we have here. The first one, mineralogy. That's the study of minerals. Remember, ology means study of. Petrology is actually what we're focusing on here. Now, geology is different. Geo meaning earth or ground, and geology is the study of the earth. So petrology and geology are different. A lot of times when we hear geology, we think study of rocks, but it's actually the study of the earth. And then being more specific, it would be petrology. Why did I include mineralogy? Because rocks are a mixture of minerals. So let's take a look at sedimentary, metamorphic, and igneous rocks. First one we'll focus on are sedimentary rocks, and the key words here are being compacted or squeezed down, pressurized, and kind of glued together or cemented together. Sedimentary rocks are actually formed from particles of sand, shells, pebbles, and other fragments, pieces. And these pieces are called sediments. And you can see that at the bottom of the page there. But when they're actually cemented or glued together, they're called clastic rocks. So clastic meaning glued or chemically cemented together. And this can be done chemically from a solution. So when that water evaporates and leaves behind some of the chemicals, they will start to solidify and kind of glue together, hold. The pieces that are actually formed are called sediments. And something you should have learned in the past are the words weathering and erosion. Weathering means breaking down. And erosion, a lot of people think erosion means breaking down, but erosion means moving from one point to another. So when we have weathering, okay, that's the breakdown, maybe wind and water breaks down the rock. Then when that rock kind of falls down to the ground, or those little pieces fall down to the ground, or they kind of roll down the hill, okay, from point A to point B, that's erosion. And we'll be talking about that later on. Now, another word you need to know, when we have sedimentary rock, if you think of the Grand Canyon has these layers, okay? The layers, a lot of times scientists say it represents a time period. We'll talk about that later on when we get to fossils. But each of those layers are called strata. So layer means strata. Okay, so here we have what we kind of already talked about. We have number one, weathering, the breakdown. And then we have erosion. Those pieces get moved from point A to point B. Then we have something called deposition, depositing. This is not the same deposition that we're talking about when we were talking about dry ice. This is a different word. This just means dropping off, okay, where it lands, deposition. And then we have compaction or squeezing together. So those are the four things. So we have a solid rock, wind or water or something breaks down the rock, okay, into little pieces called sediments. These little sediments roll down, okay, going from point A to point B. That's erosion. When they land or they rest at point B, okay, they're deposited, they're dropped off. That's deposition. And then you start creating these layers, the strata, and they get squished together, and that's compaction, okay? Now you can identify these names with different synonyms. So instead of compaction, you want to say squeezing or pushed together through pressure. That's fine. Okay, you need to know these three examples, okay? Sandstone, conglomerate, and limestone. Now, specifically in sedimentary rocks, Sedimentary rocks are going to be the rocks where you're going to have fossils. There's going to be lots of fossils, most likely in sandstone. You can see large chunks of other rocks in the conglomerate. It looks like something that if you walked over to a place that had maybe concrete or cement and it has other rocks in it, that would be an example of a conglomerate rock. Then you have limestone. We talked about the mineral calcium carbonate, calcite. Well, when calcite, actually is in a cave and goes through this chemical process, it can chemically change into limestone. It actually, will be left behind if this calcite is sitting in water and the water evaporates. It will actually chemically change in form. Now, the limestone is more brittle, and they call it that because of the light green color. Now let's talk about metamorphic rocks. Metamorphic rocks, I said this before, the key here is not just pressure like sedimentary rocks, but lots of heat. Lots of heat. There are two types of metamorphic rocks, foliated and non-foliated. Foliated means it has these beautiful bands or ribbons of flat minerals. One example of a foliated metamorphic rock is gneiss. Gneiss starts with a G, you don't pronounce the G, but GN, you pronounce the N. Gneiss is an example of a foliated rock, and I'll show you a picture. And it has the bands. And it will also, because of heat, it will also have some crystals in it. So the focus here is, remember, it's in the ground, it's not at the surface, it's in the ground. You have all this heat, and pressure starting to make crystals, so crystals can form. So there could be a lot of quartz in it, could have feldspar, so it's a mixture of these minerals. The other type is non-foliated. This means these minerals are not arranged in bands. It's more random patterns, and this could be quartzite, and the most popular is marble. Marble. Actually, marble is calcium carbonate. So if we take calcite and we turn it into limestone, remember we said limestone is a sedimentary rock, but now we take that limestone with heat and pressure, you turn it into a metamorphic rock. Limestone now turns into marble. So limestone, which is very brittle, turns into a beautiful, strong metamorphic rock because of the heat and pressure. So here's the focus is heat and pressure. Where sedimentary rocks, we had multiple things. Here we're just focusing on heat and pressure. Take a look at the pictures. Gneiss, you can see the bands, on both the right and left side. Then we have quartzite, and then we have marble. And you can see marble, those little lines in there, it's not in parallel bands. These are more random. Last one, igneous rocks. Igneous rocks are going to basically form underground by trapped cooled magma. And so basically, if we focus on if the rock starts to melt underground, or if it's formed at the surface when a volcano erupts, the focus is the rock turns to liquid. This can happen in the ground or at the surface. The rock turns to liquid and then cools. It then freezes. I said the word freeze because don't think about ice is the only thing, water is the only thing that freezes. No, remember, freezing means going from liquid to solid. This can be a rock. So when magma or lava turns into a solid rock, because magma and lava are liquid rocks, turns into a solid rock, that is the process or the state change for freezing. Some characteristics for igneous rocks are light colored, and if they're light colored, they have high silicon and low sodium. Dark colored rocks will have high calcium, iron, magnesium, but low silicon. So that's the key here. Light colored igneous rocks, lots of silicon. Dark colored, low silicon. And remember, silicon, the symbol is Si. Now, here we have coarse grained versus fine grained. Coarse grained means more crystals, large crystals. Okay, it's very rough. So if we have more crystals, remember we talked about this before, that if we have more crystals, most likely it's taking longer to cool. This is probably happening inside the ground. Fine grain means smaller crystals or not a lot of crystals or even no crystals. This means it cools very quickly. So if it's coarse grain, most likely it's within the earth taking a long time to cool. Fine grained is most likely maybe lava when it comes out of the volcano and it's going down, and then it reacts with the cooler air, it loses heat, and then it cools very quickly, no crystals. So here's those two words that tie in with your coarse grained within the earth and fine grained probably at the surface. The word intrusive. Intrusive means in the earth. So most likely these are going to be coarse grained rocks. So intrusive means it's in the earth. I-N, intrusive, in the earth. Extrusive, think of exit, going out at the surface of the earth. These are going to cool very fast. So if I say rock is extrusive, it means it's at the surface of the earth. Okay, it's on the outside. Okay, so the focus here for igneous rocks, or we can say melting and freezing. Okay, here are the examples. Okay, and I have some more on some other pages, but we have basalt versus granite. You can actually see that. Basalt, very dark colored. Well, look, low silicon. If you look at granite, okay, primarily light colored, high silicon. Okay, basalt, I don't see a lot of crystals there. It cools very fast. Granite, if you turn the granite, you're going to see some tiny little crystals. It'll have some luster. Okay, each of those little crystals will have luster, so it cools slower. It's usually going to be in the earth. So if basalt, no crystals, it's probably going to be extrusive. Granite, if it has crystals, probably within the earth, it's going to be intrusive. Okay, here's some other examples. Andesite. Andesite, if you remember maybe in history class or geography, the Andes Mountains. Andesite most likely is going to be at the Andes Mountains. Now, at the Andes Mountains, there are lots of volcanoes. Okay, volcanoes formed. Andesite looks very gray, right? Well, it's primarily made because of all the ash and the volcanic ash formed from the eruptions. And because it's coming out of the volcano, maybe ash mixed with lava, it's going to cool very quickly. And it's going to have this gray color from the ash. So basically, it's cooling quickly, no crystals, it's extrusive. Now, if I go to gabbro, those black little things, when you actually look at gabbro in your lab, you're going to see that those black little crystals, okay, do have a luster. Not the whole rock, though, because that white doesn't actually have a lot of reflective ability. But basically, the black pieces will, and so those are crystals. So if you see crystals, it's going to be intrusive in the ground, okay? And those crystals are larger, so it's going to cool slower. So gabbro. Okay, here are another set of 3 igneous rocks: pumice, scoria, and obsidian. Now, pumice has little holes, and primarily the focus on pumice that you need to know is that it is very, very light colored, but also low density. That means I can take it and I can drop it in water and it will float. Okay, scoria also has all those holes, but the focus is it's very dense, it'll sink. Many times obsidian has been used in the past as arrow tips or knives. It's very sharp, it's shiny, but the focus here and the reason why, it's because the lava is freezing very quickly. There are no crystals in it. Even though it's shiny, there are no crystals in it, and it forms at the surface. Okay, so here we have the breakdown. For sedimentary rocks, you have sandstone, conglomerate, and limestone. For your metamorphic rocks, you have gneiss, quartzite, and marble. For the igneous rocks, you have basalt, granite, andesite, gabbro, pumice, scoria, and obsidian. So these are the 13 rocks you do need to know